Hello, Pirates. Today we are going to be starting our covalent bonding unit by taking a look at some covalent basics. In a previous unit, we talked about ionic bonding, where electrons are transferred from one atom to another. The atom that loses the electrons, usually a metal, becomes a positive cation, while the atom that gains the electrons, usually a nonmetal, becomes a negative anion. This unit, we will begin to look at covalent bonding, which involves atoms becoming stable through sharing electrons. Let's take a closer look. During the ionic bonding unit, we learned about the Octet Rule, which states atoms will become stable by gaining or losing electrons so that its outermost shell has 8 electrons, like that of a noble gas. Metals will lose all the electrons in its outermost level, exposing a shell underneath that fulfills the Octet Rule. Nonmetals will gain enough electrons to have 8 valence or outermost electrons. The periodic table shows us a pattern about the number of valence electrons in non-transition elements. Covalent bonding does not involve metals, so we will only be looking at the nonmetals and metalloids. Like we've said before, in an ionic bond, electrons from a cation are taken by an anion. When this happens, it will satisfy the Octet Rule for both atoms. The anion now has 8 valence electrons, and the cation has its outermost level completely stripped away, leaving the level underneath it, which is now its valence or outermost level, with 8 electrons. Covalent bonds, on the other hand, involve two nonmetals. Since nonmetals gain electrons when two interact, one can't simply take the electrons from the other. Instead, they both have to share electrons. When fluorine bonds with another fluorine atom, they end up sharing a pair of electrons. But what does this mean? Well, when we look at the first fluorine atom, it now has 8 valent electrons, thus satisfying the Octet Rule. When we look at the second fluorine atom, it also has 8 valence electrons, satisfying the Octet Rule again. When electrons are shared between nonmetal atoms, they are able to fulfill the Octet Rule without having to fully gain or lose electrons. The concept of valence electrons is crucial for covalent bonding as it was for ionic bonding. As a brief recap, you'll recall that valence electrons are the number of electrons in an atom's outermost level. If you take a look at our class periodic table, you'll notice that there are Roman numerals below each of the family charges. This is a quick way to determine the number of valence electrons for most of the elements that we will use in this class. On this diagram, as seen earlier, you'll notice that with the exception of helium, the Roman numerals at the top of each column corresponds to the number of dots around each atom below it. Since this unit primarily focuses on nonmetals, let's take a closer look at a few covalent elements that we'll see often in this unit. As you'll learn when you begin Lewis dot structures, we draw simple dots to indicate electrons. You'll also learn that electrons are more stable in pairs, as seen on this neon atom. The noble gases, or neons family, have 8 electrons in their valence level, which means there are 4 pairs of electrons. Because there are no unpaired electrons, there are no opportunities for neon or other noble gases to form any bonds. The halogens, or fluorines family, have 7 valence electrons, meaning that you'll end up with 3 lone pairs and 1 unpaired electron. This unpaired electron can make a covalent bond or be shared with another atom so it can fulfill the Octet Rule, meaning that fluorine or other halogens have 3 lone pairs and make 1 bond. As we go backwards across the second period, we begin to see another periodic trend emerge. Oxygen's family has 6 valence electrons, meaning there are 2 lone pairs and 2 unpaired electrons, meaning it will make 2 bonds. Nitrogen's family has 5 valence electrons, meaning that there is 1 lone pair of electrons and 3 unpaired electrons, which makes 3 bonds. And carbon's family has 4 valence electrons, meaning there are no lone pairs, but there are 4 unpaired electrons, which makes 4 covalent bonds. In the coming lessons, we'll continue to explore the ways nonmetals share electrons, the way we determine how these molecules bond with one another, and how to name these new compounds. That's all for today, so have a great day and go Pirates.